Okay, today we're going to take a look at the release test questions that we have so far with the end of course test as it relates to circles. And a teacher draws a circle O, an angle RPQ and angle ROQ is shown. The teacher asks the students to select the correct claim about the relationship between a measure of angle RPQ and a measure of angle ROQ. Which claim is correct and justify your answer. Okay, when we take a look at circles, remember that when we took a look at circles, our most important part was where our vertex was. Now when our vertex was on the circle, our angle equaled half of our arc. Okay? And when the vertex lied at the center of the circle, our angle was equal to our arc. The other two things that we had to work with was when our vertex lied inside the circle, we added the arcs and then divided by 2. And if the vertex lied outside the circle, we subtracted our arcs and then divided by 2. Okay, so if the vertex lied on the circle, our angle is half of our arc. If the vertex lied at the center, the angle and the arc were the same. If our vertex lies inside of the circle, you would add the arcs together and divide by 2. And if it was outside, you would subtract the arcs and divide by 2. Okay, so we're looking at the measure of angle RPQ up here at the top. So this angle measure up here with our angle measure here of ROQ, and which one's bigger? Okay? Now, we know that those two are not going to be equal, so we know that claim 1 is going to be automatically out. So the claim that is going to be correct is claim 2. Okay? And the reason that we can say that is that the measure of angle RPQ, or the angle RPQ rather, is an inscribed angle so its measure is half the intercepted arc while angle ROQ is a central angle whose measure is equal to the arc. Okay. And to save time here in the video piece, you can go ahead and pause the video if you need to continue to write to make sure that that gets written down. Meanwhile, we'll move on to the next section. And our next question works with the equation of a circle. Okay, in an equation of a circle, okay, with a center at HK and a radius equal to R, is x minus h squared plus y minus k squared equals r squared. Now, in a couple of these cases, it might be something where we have to go through and actually complete the square. In this case, we know that our center at O is at 1, 1. And then we can count our blocks out to find that our radius is 4. Okay, our signs are going to be opposite when we put it in parentheses, so it's going to be x minus 1 quantity squared plus y minus 1 quantity squared. And since our radius of 4 is squared as well, it will equal 16. And again, as with the previous question, if you guys have any points in time as you go through the presentation, today and watching this. Go ahead and pause your tape, and we'll keep moving forward so that the video is not too long for YouTube. All right, in our figure shown, L is the center of the circle and PQ is a chord of the circle measuring 13 centimeters. What's the length of this in centimeters of PL? Okay, well, what we've got to look at here is a couple of different pieces and parts to this. Number one, okay, LM is going to be a radius. Okay, and if a diameter is perpendicular to a chord, okay, the diameter is perpendicular to a chord, okay, it bisects the chord and the arc. Okay, it's going to bisect the chord and the arc. Okay, now what that means is that my length from P to M becomes 15. And what we're going to do then is we're going to use the Pythagorean theorem in order to find our length from P to L. Okay, now remember the Pythagorean theorem, a squared plus b squared equals c squared. This part here, where the x is going to be c. So what we're going to do to solve our problem is take 8 squared plus 15 squared and let that equal x squared. Okay, so 8 squared is 64. 15 squared is 225. Those are going to combine to 289. And then we're going to take the square root of that. And that means that x is going to be 17. Okay. A lot of times when you see a diameter within a circle where you're dealing with a chord, you're going to have to use the Pythagorean theorem to solve in with those pieces and parts. Okay, not all the problems will end up where you have to do that, but generally speaking, with a circle, if you do see a right triangle, most likely you're going to need to use the Pythagorean theorem in there somewhere. Okay, the Pythagorean theorem can bail you out of a lot of different issues as you go through with some of these problems. Okay, this is very similar to our first slide. What is the measure in degrees of angle ABC? Because our vertex lies on the circle, our angle is half of our arc. So we're going to take 120 and divide it by 2, and that will give us 60. Okay, our next one. Points A, B, and C lie on a circle with a center of point Q. The area of our sector AQB is twice the area of the sector BQC. And we know that the arc length of AB is 28 centimeters. So what is the length in centimeters of arc BC? Okay. Well, we don't know a lot in this case, okay? We do know that the area of AQB is twice the area of sector BQC, and we do know that the length of arc AB is 28 centimeters, okay? So we do know that because our sector is twice the area of sector BQC, there's a couple things that we know about that. Okay, first of all, we know that we're working on the same circle. Okay, so because I'm working on the same circle, what I do know is that the measure of my arc here, or my angle here, is going to be x. And that's going to be my angle from B to C. Okay, in order for my area to be twice, keep in mind that our formula for the area of a sector is to measure the central angle over 360 times pi r squared. Well, in order for this piece here to be twice as big as the other, this is going to be the same in both arcs, which means that my arc from A to Q to B over here is going to be twice as big as my arc from B to C. Therefore, when I go to work through my arc length problem, my circumference of my circle is going to be the same as well. Okay, and as a result of that, I can take 28 and divide it by 2, and I will get 14 centimeters, and that will be my length and arc from B to C. The formulas are going to be the same, so the only way that our area can be twice the area of BQC is if our angle is twice as big. Well, when you go to the area of the arc length problem, the formula is still the same. This 2 pi r over here is not changing regardless because it's in the same circle. So if my arc is 28 here and my area was twice as big, it's going to be twice as big when it comes into my circumference as well. Okay, the equation of a circle is shown. What's the radius of the circle? All right, what we're going to work through on this is we are going to have to do completing the square. Okay, when we complete the square, the first thing that we want to do is take this 16 to the other side of our equation. So what we're going to do is we're going to rewrite our equation. So I've got x squared minus 10x plus some number blank plus y squared plus 8y plus some blank, and that's going to equal the negative 16 and plus the 2 blanks that we just plugged in. Okay, so my first piece, when I go to complete my square, I take this number that's in front of my x and I cut it in half. So that's going to give me 5. Okay, 5 squared is 25, so that's going to go in the first blank over here that I wrote way too small. We're going to do the same thing then with our y's. Okay, my middle term is an 8, so that's going to give me y plus 4 quantity squared. And that's going to put a 16 over here. Now I have a negative 16 and a plus 16 over here, which is going to cancel out. And that's going to leave me with 25. This is the standard form of this circle. Now, what we need to think about, what we're really looking for is the radius. So remember that this is r squared. So what's the square root of 25? Okay, it is 5. Now, the other thing that might be asked at some point is what's the center of our circle? So we know that our radius is 5. Our center is opposite sign. So if I have an x minus 5, I put a positive 5 in for my x coordinate for the center. Since this is plus 4, this becomes negative 4. So my center would be 5, negative 4. Even though that's not a question that we're asking right now, that is something that you do need to be aware of for that test. Okay. All right. The next one asks us to equate the equation of a center of a circle that has a center at 1, 3, and a radius of 4. Okay, so again, our general form, x minus h squared plus y minus k squared equals r squared. Okay, so it's opposite sign, so I'm going to have x minus my x coordinate. Well, my x coordinate's 1, so that's going to go inside. And then plus y minus the y coordinate of my center, which is positive 3, so it's going to be minus 3 in the parentheses. Then remember to finish off, you're going to square the 4. 4 times 4 is 16. Okay. And then the last one. Okay, this has been something that has come up from time to time over the years. And what I want you to know is that your opposite corners here to here and here to here must be supplementary. So the measure of angle A plus the measure of angle C has to equal 180. And they're not asking for angle A, they're not asking for anything up there, so we're not worried about that for the problem. We also need to note the measure of angle B plus the measure of angle D has to equal 180 as well. Okay, well angle B is Y. Angle D is 83, and those two have to add up to 180 degrees. So we'll subtract the 83 from both sides, and then Y is 97.